Okay, so let's get rolling here. First of all, let's talk about the midterm. So I put a study guide up. The midterm will be this Friday. It'll be designed to take about 35 minutes or so. You have the full period to work on it, so it shouldn't be a time pressure time pressure situation. Be all short answer essay. There may be some light programming in there, but it won't be a programming intensive exam. If there's programming, it would be on one question, something like that. And I might even ask you just to read some code rather than write some code. But don't expect it to be heavy programming. So topics covered, and we can talk about each of these a little bit today, but if you want to review these and come back and have questions on Wednesday, I'll be happy to spend some time in class on Wednesday talking about these. Or if you have questions today, we can certainly answer them today. Otherwise, we'll keep trucking. The last thing on here is the JSON structure and parsing, the stuff that we're working on right now. Okay, so first thing, history of Bitcoin. So kind of the overarching backstory there, the Mt. Gox stuff, Bitcoin being SHA-256 and what things have kind of come out of that, just the overarching story of Bitcoin. Number two, I separated these, blockchain. And we're going to talk a little bit about the blockchain today and some interesting stuff, kind of giving you a foreshadowing of what we're going to do the second half of the semester. But the blockchain in and of itself, you may have, in the news, you may read things about blockchain technology. So we'll talk a little bit about what that means in general today. But, the idea of the blockchain, how it's a public record of all transactions that have ever occurred, that type of stuff, certainly fair game for the test. The role of mining in cryptocurrency systems, what do miners do? Why do we need them? That kind of stuff. How coins are created as a result of mining. Process of sending coins to a recipient. Similarly, how do you receive coins? How do Bitcoin wallets work? I guess that would go into the category of receiving coins. How does it work in terms of a wallet parses the blockchain, looking for coins that belong to a unique address? Make sense? Turing complete. What is meant by Turing complete? What is a hash? So hash functions in general, we would say, is a one-way cipher. When we think about a single hash as it relates to cryptocurrencies, we might say it's a guess. How are hashes created with Bitcoin? ASICs, application-specific integrated circuits, so specialty machines built specifically for mining Bitcoin or mining other currencies, script-based currencies. How does the Bitcoin network difficulty work? What's the purpose of it? Why do we even have this idea of a network difficulty? Why should it be able to go up and down, and what benefit does that give us? The concept of proof of work in terms of validating a block. What is a nonce? Cloud versus hardware mining. Pros and cons of each. That kind of stuff. Then we get into some of our things we've dealt with lately with the APIs. Get versus post. HTTP requests. What is an API in general? XML versus JSON for data representation. Details of our Coinbase payment system to minimize transaction fees. So there might be a question or two on there about specifically what we're trying to accomplish with our, I guess we sort of already accomplished the transaction stuff, and now it would just be a matter of tossing it into an app where you actually have the full-fledged, scan a QR code to get the address and push a button and you're done. But in terms of the guts of it, sending and receiving transactions is there. And then JSON structure and parsing, kind of the idea of parsing. All right, so given that as the kind of the list of topics, are there any questions initially about that? Like I said, I would encourage you to review this stuff and come back with questions on Wednesday. I'll be happy to answer them, but if you have questions now or want me to review any of these, I will. Okay? So like I said, the exam will be Friday. So we'll spend the rest of today doing our normal stuff. Wednesday I'll take questions, and then we'll keep doing normal stuff. And then Friday you'll come in for an exam, and I'll get those back to you on Monday. So you'll kind of know where you're sitting for your midterm grades. Okay. Now, we'll return back here to our parsing here in a moment, but let's talk about blockchain technology in general. Up to this point, when we've discussed the blockchain, we've kind of discussed it as, oh, this is just how Bitcoin works, right? One thing that we're going to consider in the second half of the semester is the real value in a cryptocurrency the coin itself, as far as buying and selling things, or is it the blockchain technology? What would you say is interesting about the blockchain? What do you like about the blockchain? This maybe even plays into a little bit of a review for the test. If somebody were to ask you on an exam, tell me what the blockchain is and give me some pros and cons of it. What's good about the blockchain?
That every transaction to ever happen is there.
It's transparent. Every transaction that's ever occurred is publicly available. Everybody can view it. That's good. What's bad about the blockchain?
The size, the sheer
it's huge. Yeah, it's huge. There's tons and tons and tons and tons of transactions, and every single day there's more transactions. So the blockchain gets arbitrarily large. Well, maybe we can say that's a good or a bad thing. Would public transactions be okay if the blockchain had actual people's identities in it? Probably not. So another feature of the blockchain, kind of piggybacking on what State Farm said initially, is if we have every transaction that's ever occurred and they're anonymously recorded, that is, we have unique hash addresses rather than people's names, that's advantageous, right? So try to think about the blockchain from the perspective of what it actually is rather than one of the problems we apply it to, which can be Bitcoin. Sending Bitcoins to people and keeping Bitcoins in your wallet and all that stuff. What we're going to look at in the second half of the semester is the creation of a product that leverages the Bitcoin, or leverages the blockchain, but really has nothing to do with cryptocurrency. It's going to be kind of an interesting stab. So the idea is this. We've identified a problem. And what we're going to end up doing is we're going to end up trying to publish this. So as part of the second semester, our final project type thing is we're going to have a paper that will have all of our names on it as co-authors and will get published. And you can then put that on your resume. So it'll be kind of a fun thing. Well, so we have a problem, and that is voting. So every single year when we have elections and things like that, we have an issue with being able to count votes, validate votes, people being able to vote in the first place. Well, what if we took the voting problem and came up with a solution that leveraged the blockchain for actually doing the votes and also validating the count for votes? Kind of get where I'm going with this? So, we'll talk about the details of it, but that's kind of the foreshadowing approach there, that we can use something like Bitcoin. So maybe we leverage Bitcoin's blockchain network, and we're using Bitcoin not as a currency, but as a tabulator for votes. And the validation of the votes comes through the blockchain. Maybe we're sending, if you vote for person A, it goes to a certain address. If you vote for person B, it goes to another address. And we're going to try to kind of approach various problems of voting. One of the other problems, obviously, is making sure each person can only vote once, as opposed to having one person voting 30 times for all these dead people and stuff like that. So, kind of an interesting project to apply the blockchain, because this is almost something that we need to be as, let's just say, advocates of cryptocurrencies, we need to be realistic about the reality, about the situation that cryptocurrencies may not win. We might not switch over our entire monetary system to Bitcoin. That doesn't mean there wasn't lessons learned or there isn't valid reasons to utilize Bitcoin. So it could be more than just, hey, I'm going to buy a Chevy with Bitcoin. We can apply that blockchain or the currency itself to validation of other problems. So that's going to be a problem we're going to look at. Okay, so let's get back to our parser here. Last time at the end of class, I think we tested this on generic data, what we called simple JSON. So we spent all this time and complexity only to do what we were already doing before. But it did work. So now I went ahead and I updated inside of our main to go to a different portion of the API. This is to list all current transactions. And this guy has more complex data. So we have a value called current user, or a variable named current user, whose value is a JSON object. And as I go through this, I believe we have an array of transactions. Yep. So then we have transactions, and inside here we have an array of those transactions. So we should be able to fully test the rest of our thing using this. Okay. So getting back to our JSON parser, where we left off last time, we had this spill-through approach. So we went through potentially every character inside of temp. If we were currently capturing the variable name, we would capture it until we had a quote count of 2. And then we were done capturing that variable name. Then we'd look for that colon, the separating piece between our variable name and our value. Then we're going to start capturing the value. Well, we're going to start figuring out what kind of value we're going to capture. If we run into a double quote, we know we're capturing a simple value. Should capture simple as true. And we'll go ahead and grab that opening double quote. If we find an opening curly brace, we know we're going to be capturing the value. Specifically, it's going to be a JSON object value, and we'll go ahead and grab the opening curly brace. If we find an opening square bracket, we're going to go ahead and capture that. Say we're going to capture the value, mark that we're going to be capturing a JSON array, and tack on the opening square bracket. Otherwise, we're going to get that dumb value, things that don't have double quotes after it, which I'm not necessarily convinced are legal in JSON, but we'll just deal with it. So that's our bailout, if it's not one of those things. Okay, this is what we wrote last class, this portion, if we're capturing a simple value. So as soon as we run into that closing double quote, we know we're done capturing our simple value. And we'll go ahead and grab that final double quote. And that's where we finally fall into this else, which means we've already completely captured a variable name, completely captured a value, and now if we ran into a comma, we're going to go ahead and record that variable name and value as a JSON var, stored in the vars, and then reset everything. Okay? Now, remember, after this loop is done, if var name still has something in it, that is, we may have had one final variable that we didn't actually record yet, we need to go ahead and grab it. Because we only did this if we found that comma. So the very last time through, we're going to have one extra variable. Okay, so what we want to do now is deal with capturing a JSON object. That is something that starts with an opening curly brace and ends with a closing curly brace. Okay, if we're in here, we've already grabbed the opening curly brace. So as we're walking through a value, we have an opening curly brace, we're looking for the corresponding closing curly brace. And we want to just capture everything in the middle up to that point. Right? And every single time we hit an opening curly brace, we need to increase our number of curly braces found. because you might have opening curly braces inside of there, because we're not doing the next depth of parsing. I think a couple of classes ago you mentioned that we're going to have to eventually do this recursively. Because you could have JSON objects inside of JSON objects inside of JSON objects. But at this point, we're trying to differentiate our top-level variables, top-level values, and just getting strings. Here's a simple JSON value. Here's a JSON object type value. Here's a JSON array type value. Okay, so we're going to have to add another variable up here.
Why does it need to be up there?
Well, we don't actually have to add it up here. Well, we probably need to create it up here because we don't want to reset it every single time inside the loop. We're going to keep track of the number of quotes. So the variable I'm going to have, not quotes, curly count. So curly count's going to start off at 0. And just so I don't forget, since we just zeroed out curly count, I'm going to go all the way down here to that else. I'm going to throw that in there. That's part of resetting the whole process.
Do you technically need to do that?
What do you mean?
Because if you eventually, once you're done with a JSON object, it should be 0. I mean, to be safe, it wouldn't.
Yeah, you're right. You're right. If you finished, it should be back to 0. Yeah, you're right. This isn't necessary. I guess I prefer this just because it shows you we're resetting everything, but you're right. Now, as soon as we find that opening curly brace, and this is actually another argument in your favor. So when I find that opening one, I'm going to go ahead and set curly count to 1. I just found 1. Make sense? So that's essentially resetting it in and of itself. Whatever it used to be, now it's a 1. I found 1 opening curly brace. So as we're walking through here, remember, we're building our var val. So I'll go ahead and grab that line in here. We're doing that regardless. But now what we're going to say is if temp.charat I is equal to an opening curly brace, then we're going to say curly count plus plus. Else if temp.charat I is equal to a closing curly brace, we'll say curly count minus minus. Make sense? So every single time I find an opening one, I'll increase my number of curly count. Every time I find a closing one, I'll decrease my curly count. Finally, I'm going to have another if statement. If curly count is equal to 0, that means I have found all my curly braces. I'm done recording this guy. Okay, if that's the case, I want to say should capture JSON object equal to false. Make sense? I found the endpoint of this particular JSON object. Have my opening curly brace, and regardless of how many other opening curly braces I found in there, I should have found the equivalent number of closing curly braces. Again, this all assumes that we have legal JSON, that somebody didn't give us bad JSON. So in the simple case where we have an opening curly brace and a corresponding closing curly brace, curly count would be 1, curly count becomes 0, found the closing one. Right here we do curly count minus minus, then we just ask the question, if curly count is 0, we are done reading in our value. We'll go ahead and just grab that closing curly brace right there, and then the next time through our loop, we'll drop it into the else. That make sense? Similarly, let's call this bracket count. Start that off at 0. Let's follow the exact same pattern. So I'll steal that to reset it down here. Again, not necessary, but we'll still do it. we're looking at an opening square bracket, we'll go ahead and grab it, and we're going to set bracket count equal to 1. We just found our opening guy. So now we're inside this Json array, which we set to true up here. If we found the bracket, we're going to say should capture Json array to true. And we're going to do something pretty similar to what we did in here. So I'm going to steal that code. We'll paste it in here. But we're looking for opening square brackets and incrementing bracket count, closing square brackets, decrementing bracket count, and then checking if bracket count is equal to 0 should capture Json array is false. And we'll go ahead and grab that closing bracket for the last part of our value. Okay. So that should handle arrays. We won't get the meat of the array yet. We're going to have to build the modules to do that, but right now we'll at least say, here's my variable name, and its value is an array with all this crap in it. Here's my variable name, and its value is a JSON object with all this crap in it, so on and so forth. Now, how do we handle dumb objects or dumb values? Things that don't start with a double quote, don't end with a, or don't start with a double quote, don't start with an opening curly brace, and don't start with an opening square bracket. That's in this else portion right here that says, if I'm looking at something that's not a space, if it's not one of those other guys, it must be one of these dumb values. Go ahead.
Do you want to just capture whatever it is and find out, and then just say it's done when you find it again?
Well, how do we know it's done? So let's just say that it's a number. So it's the number 42. So I just ran into a 4. The 4, it's true that the 4 is not a space, correct? Wasn't a double quote, wasn't a curly brace, wasn't an opening square bracket, but it also wasn't a space. So I just ran into something that was not a space. I'm going to go ahead and grab the 4. We're going to say we're going to capture the dumb value. How do I know it's done?
Look for a comma.
Okay, could look for a comma. What if it's the last value?
End of string.
Okay.
No, I think it's better a closing bracket.
Closing curly brace?
Yeah.
Except we took those off.
The last
Yeah,
one.
right at the beginning, we took them off.
Or maybe you can try to parse with the. Hold on.
Well, does a comma work? If this is the value, the very next thing we'll run into is a comma,
Yeah.
right? What if it's the last value?
Then you'll run
We'll run into the end of the string. So if we were in the process of reading in a value and we ran into the end of the string, are we okay? Will this little section here do what we need it to do? This guy right down here. We'll go ahead and catch it for us. Now, what if we hit a space? Does space mean that we're at the end of the variable as well? Can we have what we're calling a dumb variable? Can we have a dumb variable that has spaces in it? No. In fact, we might even argue we can just barely have a dumb variable, right? We're going to support these, but having a space in it doesn't make any sense. So to stay consistent with what we're doing up here, we actually don't need to do a space count there or anything. So we'll come in here, we'll go ahead and grab the first part of that dumb variable. Then we'll drop down here where we're actually capturing the dumb value. And we're going to say, if we're looking at a space, we're currently looking at a space, we know we're done, right? So we're going to say should capture dumb value is equal to false. Or you mentioned, what if we're looking at a comma? This potentially breaks for us, doesn't it?
You can like decrement the I variable.
Ah, okay, good. So what he wants to do is, in the situation here, where we have, they had their dumb variable, 42, let's say, with a comma immediately following it. No spaces. So we'll actually hit the comma before we were supposed to hit the comma. That makes sense? So what we're going to do here is, if it's a space, we'll go ahead and say we're done, and we'll grab our value. Actually, we don't even want the value. We'll say we're done. Else if temp.char@I is equal to a comma, we'll also say we're done capturing this dumb value. So the next time through, it'll get to this else, but we're also going to say I minus minus. Kick it back a space so that the next time through, it reads the comma again. That make sense? That way, we properly hit the end of that guy there. So we read the 4, we read the 1, got to the comma. Oh no, I've read too far because this was a dumb value. So I'm going to go ahead and mark that I'm finished reading my dumb value. It's currently inside of var val, but let's kick I back 1 so that when we re-loop, we say I plus plus. So I basically remains the same as it was last time. That is on the position where the comma is, but we will get into this else down here because we set should capture dumb value to false. Does that make sense how that's working? So we're kind of short-circuiting our loop. Else, if it's not a space and it's not a comma, it must be part of the dumb value. And what do we do with parts of the dumb value? We capture the dumb value. Make sense? Okay, so that should complete version 1 of our top level, fully functional JSON parser. Let's go ahead and test this. So after we read it in, we'll run it through our parser, and then we'll tell our parser to display itself. And what that does is it goes through and tells each var to display itself, where this says here's the variable name and here's the corresponding value. So we should have some simple values in here, we should have some JSON object values in here, and we should have some JSON array values in here. The array values are going to be the biggest value because we're not differentiating the JSON objects within it. We're just saying, hey, here's an array and all the crap that came with it, with the closing square bracket at the end. Just proving we found it. Okay? So we have our current user, which is a JSON object. We have a balance, which is a JSON object. We have a native balance, which is a JSON object. We have a transactions, which is an array. Really long array. We're just interested in the closing square bracket at the end. I knew I shouldn't give it out my API
too far.
Scroll too far.
See, hold on, did I? Oh, right here. Well, then what was this guy?
That's the entire.
Oh, that's an
thing.
object. Oh, that's the whole string. Thank you. Yep, so there's my closing bracket, so we found that.
That was a lot faster. Going back.
I got aggressive. I think the trackpad just is, okay, I get what you mean. Okay, gotcha. You're done. Okay, so then here's some simple JSON. Actually, no, this is dumb. Dumb JSON, that worked. Another dumb value. I really don't think that's legal JSON.
I think it is. You can,
Yeah.
It's for
For
type it values like
Yeah.
boolean or
Really?
integers.
But can't you just discern that from the string?
I suppose, but
Because so let's say we support ints and booleans, like you're saying. You're still going to have to look at it. Is this the word true or the word false? If not, it must be an int. What about chars? Does it support a char as just a, or does that have to be represented as a string?
I don't think it would have chars. I think it would just be a string.
Well, I think it's sent to you, the entire thing is sent to you as a string. So
Yeah, it's just dumb. Just dumb. But we support the dumb values. That's the official name for it, is dumb values. All right. So now we are accurately parsing at the top level. How do we now handle internally parsing a JSON object? What is a JSON object? A JSON object is a collection of JVARs, or JSON vars, correct? JVARs is what we use on the street. It's street slang for a JSON var. All right, so if this is a JSON object, its values would need to be stored as a collection of JSON vars. That is, variable value pair, variable value pair, variable value pair. So really, we need to be able to parse out value from a JSON var. A JSON var should be able to give us the type of value it is. So let's start with that for beginners. JSON var, when it gets its value, it can determine what kind of object this is, correct? So I'm going to add a variable here just for now. We'll just call it private string type. And inside here, we're going to say if value.charat0 is equal to a double quote, type is equal to simple. Else if it's an opening curly brace, type is equal to a JSON object. Else if opening square bracket, it's a JSON array. Else just dumb. And now what we'll do is, as part of the display for a JSON var, let's just put in parentheses here. The type. So now each of our variables should differentiate themselves as to what type it is. So we know about it inside of a JSON var. So current user was a JSON object, balance was a JSON object, native balance was a JSON object, transaction was a JSON array, total count was DOM, num page is DOM, current page DOM. Okay, so our JSON vars now know how to identify themselves. Could we then ask a JSON var to further parse itself? So if the value is simple, we don't have anything to do. The value is dumb, we have nothing to do either, correct? If the value is a JSON object, what do we need to do to truly get the value of it?
Parse it again.
Okay, and how do we parse it again?
By calling parse.
Send value to
JSON Parser. This is the guy that knows how to get that, right? Now, in the end, JSON Parser has something called the vars, correct? And we haven't given ourselves the ability to grab the vars. We've just given ourselves this thing called display. So what if we did this? We'll just do this for the time being. If I'm in JSON var, and I've noticed that something is simple, this is fine, this will work. Let's say it's a JSON object. Let's just write it for the single one right here. So we have a JSON object. What I'm going to do is I'm going to create a JSON parser equals a new JSON parser. And this guy's going to take in our value, which is JSON, right? Remember, our JSON parser accepted a JSON string, and it did the rest of the magic. So we will pass it that, and then we'll say jp.display. So whenever we create a JSON var of type JSON object, it's going to go ahead and parse that and do a screen dump of that. So things will be in a little bit of a weird order, but we should see a bunch of our simple JSON values spit out. So before we got to current user as a JSON object, because that happened when we called display on JSON var. Before we got that, the constructor for JSON var went ahead and parsed that stuff out. So everything up here is the meat of current user. That is an ID, which was this, an email, which was this, a name, so on and so forth. Those are the pieces of our JSON object. Does that make sense? What about JSON arrays? How do we parse JSON arrays?
Filling the square brackets off and parsing them.
Okay, so what is an array? If we look at this array here, this is just the JSON object, right? Does it have a variable name associated with it?
Yes.
No variable here. An array is a collection of values.
So wouldn't you just do take off the square bracket and do a split on commas, and then that would give you an array of those JSON objects or whatever else is in it. Then we go back to the thing where if it's a JSON object, now it parses itself.
You would think so, but what if your JSON objects are sufficiently complex where there's commas within them? So essentially in the simple case right now, I have a square bracket followed by a bunch of simple JSON objects, where each of those JSON objects is self-contained. And in fact, actually, every one of those JSON objects would likely have commas in them. Not in the unlikely, they would almost always have commas in them. So splitting on a comma is just not going to work. But in the simple case, I have a collection of comma-delimited JSON objects, where a JSON object is an opening curly brace, a closing curly brace, with comma-delimited JSON vars in it. Say this again?
You could have a curly count, and then when the curly braces are equal to 0, then you can split on the comma, and that would take care of accidentally splitting on commas in the middle of the list.
Okay, so we need to parse through an array very similarly to how we parsed our JSON objects before, except right now we don't have variable names associated with them. So we're kind of seeing the definition of an array. So the definition of an array is a collection of values under a single variable name. So if we think about this in terms of Java, those of you who are in the 250 class, we haven't quite gotten to arrays, but the point is an array is a collection of stuff under a single variable name, just like a string is a collection of chars under a single variable name. All right? So I don't have variable 1 is equal to this value, variable 2 is equal to this value, variable 3 is equal to this value. I have variable name is equal to all of these values. Bucket 0 is this value, bucket 1 is this value, bucket 2 is this value, so on and so forth. So what you guys want to do is you want to walk through our value one character at a time, counting curly braces. And as soon as we get to a curly brace count of 0, what we just collected was a JSON object. Correct? And JSON objects can do what? They can be passed to our Json parser. Now that JSON object might have a JSON array inside of it. So this might be one of these perpetual things, right? But it's going to end up recursively calling itself until we get one giant object. Right now we're not really storing them in any sort of structure, but we will. But just kind of looking at this at the high level, if I want to deal with arrays here, we need to build each object. And then parse it for every JSON object that's inside that array. So we'll go ahead and do the simple version of that real quick. So we'll have an int curly count is equal to 0. We probably want to go ahead and we don't need to peel off the square brackets actually. No, we're fine. So what we're going to do is we're going to have a loop for int I is equal to 0. I is less than value dot length I plus plus. So we'll walk through the entire string that is our value. If we are looking at an opening curly brace, I just write it like that. Makes sense. If value dot char at I is equal to an opening curly brace, then I want to start capturing a value. So inside here, I'll say string val is equal to the empty string. So we'll start it off as nothing. So if we start off at if we're looking at an opening curly brace, we're going to say curly count plus plus. Else if val dot char at I is equal to a closing curly brace, then we'll say curly count minus minus.
You need another equal sign.
Else, well, if we find that, we're going to plus plus. If we don't find that, we're going to, or we find this, we're going to do minus minus. We're always going to say val is equal to val concatenated with value dot char at I. So we'll always do that. Then we want to ask the question. Well, we might want to ask the question before this. I need to know if val, or if curly count is currently 0, then I have a value. Curly count's equal to 0, then I have a value. What we need to be careful of here is, what if curly count started off at 0? Which it does. And what happens if I happen to have read in a space? Then val would actually be something with just space, just a space or spaces in it. And that's not an acceptable first variable, right? So we got two options. We can peel off the opening and closing square brackets, then trim it to ensure we don't have leading spaces. Or we can do what? If count is equal to 0 and val dot trim dot length is greater than 0, that is, val is not just filled with spaces. Okay, so if we are at a curly count of 0 and we actually have a val, then what are we going to do? Actually, I want to actually do this in two separate steps. You'll see why in a second. Curly count is 0, then if val dot trim dot length is greater than 0, that means we actually have a real value. And if we have a real value, what are we going to do with it? Create a Json parser, passing it our val that we just finished building, and then tell it to display itself. And then we'll say val is equal to the empty string. Else, if the length was 0, are we going to do anything with it? Nope. And we don't need to set it back to the empty string because it already is the empty string. We don't need to set curly count back to 0 because it already is 0. So this should handle those guys. So if I'm looking at an opening curly brace, increment curly count. If I'm looking at a closing curly brace, decrement curly count. Always read in the current val. As soon as my closing curly braces hit 0, then, as long as I really captured a value, let's go ahead and parse it. Do I have to deal with the commas here? It's just going to skip right through the commas, right? Or will it? I might put a comma into val. Can't have that. So what do I do if I have a comma?
If the curly count is equal to 0, then and the char at I is equal to a comma, don't put anything in, and just pass.
So commas I want to skip. Just move ahead.
Yes, in the event that it's not part of a value.
Can commas be part of a value?
No. Maybe.
Certainly can be.
Yeah.
We might be in the middle of capturing a JSON object, and that JSON object might have commas in it.
I think you can put this if inside the when curly counted to.
You want to put it in here?
Yeah.
Okay. So you want to say if we're looking at a comma and curly count is 0?
Yeah. Because you find one object and close it, and then you find a comma.
Okay. Because we wouldn't have hit this guy yet.
Yeah.
We wouldn't have hit this guy yet, which means that what we really need to do is this guy probably shouldn't just be sitting on his own. We need to deal with this guy. So let's put a little note in here. In the event we need to find a comma. Because we want to make sure we don't read that comma in. Does that make sense? We don't want to tack a comma that is separating our JSON objects onto our value. All right, so we'll come back next time. We'll pick up from there. Remember, if you have questions on the midterm, bring them with you on Wednesday. Otherwise, I will see you then.